Let's take a look at this. So we're going to look at some more systems of equations, just practicing how we solve them, and specifically looking at a larger type of word problem. All right, so in this word problem, this might look familiar, this word problem, you have a grocery store manager looking to order a large quantity of chicken wings for an upcoming sale. And they have two options for ordering the chicken wings. They can order from Maple Lodge Farms, which they'll be able to get a box for $5, plus $150 shipping fee for the entire order. Or they can order directly from a local farmer's market to avoid the shipping charge. But it will cost $520 or $520 per box instead. Okay, so these first couple of questions, let's just go over what's the better option given a certain number of boxes we want to order. So let's say we want to order 200 boxes. So what I'll do is I'll label one Maple Lodge and the other one the farmer's market. So what we can do is we can calculate out the price for each of them. So I'll do the total price, T for total price. And in the first one for Maple Lodge, well, it's $5 times, 200 boxes. And then plus $1.50. Not $1.50, sorry. $150. Okay, so if you calculate out the first part, 5 times 200, that's just 1,000 plus 150. And you end up getting a price of $1,150. Okay, what about the farmer's market? So the farmer's market is a little bit of a simpler calculation. You just have to do 5.2 times 200. And if you do that calculation, what you should get is 1,040. So the farmer's market would be the better option in this case. All right. What if we ordered more boxes? Would that change? So I'll just say farmer's market is the better option. Okay. So now let's move on to the second one. What if we ordered 400 boxes? How would things change? So again, we can split it up into Maple Lodge and the farmer's market. Again, we can start off total price T. So we can this time say $5 times 400, because it's 400 boxes now, plus $1.50. Not $1.50, $150. And in this case, you'll get 2,150. What about for the farmer's market? So for the farmer's market, the total is going to be, 5.2 times 400. And if you do that calculation, you should get 2,080. All right, so farmer's market is still better. But what you might notice is it's closer in price now to Maple Lodge. So there's a $70 difference, whereas if we look back at A, there was a $110 difference. And if we were to keep adding more and more boxes, that price would get closer and closer and closer. And eventually you'll end up getting the same price at sum total. And so that's what we're going to want to find out. When does that occur when they're the same price? But before we get to that, let's just create a general equation for both of the situations. So Maple Lodge, what's a general equation that represents the total cost for them? Well, what you could say is we know it's $5 times the number of boxes. So we're going to let N, I'll just write this at the top, let N represent the number of boxes. And so we can say 5.0 times n. And then every time we have to add that shipping fee. So we can actually create this general equation for the total cost. So I'll also just say that T represents total cost. All right, what about the farmer's market? So let's just section this off. For the farmer's market, same idea, the total cost, but this time now it was $5.20 per box. So 5.2 times n. And in this case, we don't even have a shipping fee, so we don't have to add anything at the end. All right, so I will just note these two special values that we have. All right, and now what we want to do is we want to graph these equations. We have a big table here. What I'm going to say is the graph in terms of what we have, the x-axis, that's going to be the number of boxes. And the y-axis, that's the total cost. Because the total cost depends on the number of boxes we decide to purchase. So in the bottom left, we're going to do 0. And for this, I'm going to do every 2 is going to be 100. So something like that. And I'm just going to label it every so often. So 400, 500 is going to be here. 600, 700. I'm not labeling as many by that title because it's just in the way. So let's label it like that. And to 1,000. All right, and the total cost? Well, the total cost, what we're getting around, we were getting like, if we just look back, 1,000, 2,000. It's going to go up to 3,000, 4,000. So what we're going to do is let's do every 2. Let's do it every 400. So 400, 800, 1,200. Or, no, let's just keep our numbers a little near 500s. And then that really keeps it simple. 2,000, every 4 is 1,000. 3,000. And 4,000. All right, so how are we going to graph this equation? Well, we actually already have some points. So we're going to graph both the equations. So let's use the values from A, and we're going to do it in different colors. But we can begin by using our equations. So here, let's write down our equations again. So Maple Lodge, that was, the total cost is 5.0 plus, 5.0n plus 150. And Farmer's Market, we'll do that down below. That is just 5.2n. Okay, so let's just focus on working with Maple Lodge Farms right now. So we're going to do that in purple. And what we can do, if we're ever graphing a line, we can always start with the y-intercept. These are written in slope y-intercept form, so that number at the end, in this case the plus 150, that is our y-intercept. So every 1 box is 250, so it's a little bit above, like that. And then let's graph out those points that we already plot or determined. So at 200 boxes, we know there's 1150, or it costs 1150. So go to 200 and go up to 1150. At 400 boxes, it costs 2150. So 400 and 2150. So something like that. We have 3 points. We could draw a line through that. and then we can graph out the other equation. Okay, so let's draw this down with a ruler again. We want to be as accurate as possible. And try to keep that as going for as long as possible. All right, that's graph number 1. So graph number 2 is the farmer's market. So the farmer's market, if you try to check out what's the intercept there, or not the intercept, yeah, the y-intercept, well, there's no plus or minus at the end, so that just means we start at 0. So below the graph of Maple Lodge Farms, which also means it's cheaper to begin with. Then let's grab 2 points. So again, go up to what you did previously. We have a price of $10.40 and then a price of $20.80. So $10.40, so just a little bit above 1,000, and then $20.80. So getting a little higher. And I'll just put down some other points. So when you get to 600, $10.40, $20.80, what's going to happen is it's going to be 3,120. So getting even closer. And if you kept going, let's say the 800, it would actually get above. So let's draw our lines using that. So it is a little tricky. They are very close to each other, so this does make it tougher, but it can still give you an idea. Oh, sorry. The tablet is acting on its own there. All right. Here, I'm going to try that one more time to really try to get it to go through those points. Something like that. And especially as you get to the end, they'll be very close, so it's hard to distinguish the two. But you can see as they get closer and closer, around like the 700, this mark right about here. And because the lines weren't drawn perfectly, if you used a graphing program, you'd be able to get them perfectly. But what I can say is they intersect, if you use that graphing program, at 750, or n equal to 750. And so you could actually go ahead and double check that. So what's the total price at 750? Well, you could check with Maple Lodge. At 750, the total price is, well, 5 times 750 plus 150. And if you calculate that out, well, 5 times 750, that's going to give you 5 times 750, that will give you 3,750. And for the other one, farmer's market, or sorry, 3,750, but then you have to add 150, so you're going to get 3,900. At the farmer's market, well, 5.2 times 750, guess what that's going to get you? Again, 3,900. So you get the same answer, which is what we were looking for. All right. So that was how we could check our solution. And in general, when we're checking a solution of just like some abstract line, what we can always do is double check, does that point, does that work in both of the equations of the lines that we have? So we just substitute in the x and the y coordinates that were given, if we're looking at a point, and then check, is the left side equal to the right side? So for example, in this example, we want to just check that is 2, 3 the solution to the following system of equations. So again, if you have 2, 3, that means your x value equals 2, your y value equals 3. So checking on this equation to the left, well, you'd substitute in for y, 3. So does 3 equal to 2 times 2 minus 1? So left side stays the same, and just work out what is the right side equal to. Well, 2 times 2 is 4, subtract 1, and so 3 is equal to 3, which is what we want. So there we've checked that this equation works. But does it work for the other equation? Well, let's see. So y plus x equal to 5. So replacing our values, 3 plus 2 equals to 5. And does the left side actually equal to that? Does 3 plus 2 actually equal 5? Well, it does. So we have 5 equals to 5. So that equation works. So therefore, 2, 3 is a solution. All right. And so that's a look at checking your solution.